Silent I/O storms, a Debian 12 revelation. Unforeseen kernel changes trigger catastrophic storage performance degradation. The recent migration to Debian 12, a project undertaken with considerable anticipation, swiftly devolved into a critical operational challenge characterized by a sustained and alarming increase in I/O activity. Initial assessments indicated a disruptive I/O storm manifesting as a continuous data transfer rate of approximately 500 MB/s, directly impacting our core storage infrastructure.
This unanticipated issue stemmed from the implementation of cgroup v2, which fundamentally altered the kernel's methodology for allocating dirty page budgets, thereby negating previously optimized system configurations and precipitating a significant performance decline. Our team swiftly mobilized to diagnose the root cause, meticulously differentiating between genuine system anomalies and misleading indicators, ultimately uncovering the nuanced impact of this kernel update.
This experience underscores the critical importance of thorough pre-migration testing and a deep understanding of kernel-level resource management within modern Linux distributions.
The kernel's shifting sands, understanding the implications of cgroup v2 for storage performance. The pervasive issue of elevated I/O activity within the Debian 12 environment represents a microcosm of a broader challenge facing the Linux kernel community: the complex and often unpredictable interactions between new kernel features and established system configurations. The introduction of cgroup v2's revised dirty page budgeting algorithms, while intended to improve resource isolation and management, inadvertently disrupted the delicate balance established by our previous settings, leading to a cascade of downstream effects on storage performance.
The underlying driver architecture, optimized for older kernel versions, failed to adequately adapt to the new kernel's approach, resulting in inefficient I/O handling and ultimately, the observed data deluge. This situation highlights the necessity for proactive monitoring and a granular understanding of kernel internals, particularly when transitioning to new releases, demanding a shift in DevOps practices towards more rigorous testing and validation.
Deconstructing the storm, cgroup v2's impact. Analyzing the root cause of the storage performance crisis. The investigation into the disruptive I/O storm revealed a critical interaction between the newly implemented cgroup v2 features and the existing storage drivers. Specifically, the revised dirty page budgeting mechanism, designed to prioritize specific workloads, inadvertently starved our primary storage subsystem, causing a backlog of dirty pages and triggering a sustained, high-bandwidth I/O loop.
Furthermore, the default configuration of cgroup v2 failed to account for the specific characteristics of our storage infrastructure, namely, the reliance on a high-performance, low-latency storage solution. This misalignment between the kernel's resource management strategy and our system's requirements created a fundamental conflict, exacerbating the problem and driving the observed performance degradation.
The meticulous mapping of symptoms and the subsequent identification of red herrings, including potential network bottlenecks and application-level issues, ultimately confirmed the kernel's role as the primary catalyst for this disruptive event.
Navigating the aftermath, risk mitigation and future strategy. Forecasting potential consequences and defining strategic next steps moving forward. The experience with Debian 12 and cgroup v2 necessitates a fundamental reassessment of our operational strategies regarding kernel upgrades and storage system optimization. The potential for unforeseen performance degradation remains a significant risk, particularly within complex, distributed environments, demanding a more cautious and iterative approach to system updates.
We must prioritize comprehensive tested protocols, incorporating rigorous I/O performance benchmarks and detailed monitoring of kernel-level resource utilization before deploying any significant kernel changes. Furthermore, investment in tooling capable of proactively detecting and mitigating I/O storms, potentially leveraging kernel tracing and advanced I/O analytics, will be paramount to preventing similar incidents in the future.
Ultimately, this incident serves as a critical learning opportunity, reinforcing the importance of continuous system observation and a proactive stance towards evolving kernel technologies.